So about this talk, I was actually at the first GraphQL London meetup. I was talking about different GraphQL clients. I presented 3 of them. 2 of them are still in use. The other one, not so popular anymore. So about me, I'm a software consultant from the Netherlands. I flew over here today to give you guys this talk. And I've been working in different customers, different microservices environments. You might not know all the Dutch companies I've worked for, but one is not even Dutch. It's the eBay Classifieds group. It's has brands like Marktplaats, which is what we call our Gumtree. And I was also working at the Dutch Amazon. It's called bol.com. Weekamp is another Dutch retailer, and different other big Dutch organizations, some of which did some microservices architecture. I'm also a contributor to swagger-to-graphql. And I recently created GraphQL Transform Federation, and I got inspired to write this talk. So I think GraphQL is ready for microservices, and I'll tell you guys why. So microservices, of course, there's lots of definitions there. So before I start, I'd actually like to give my own definition, because I think we're all past the discussion how big is a microservice. But one requirement that I have for microservices, it should consist of an organization with multiple teams working on an application together. And this a service should actually be able to function independently. And with function, I mean it should give business value. And independently typically means that it has its own database. The service should also be able to deploy it independently. Each team should just be able to code, hit deploy, and then go. There should not be much coordination with all the different microservices team. Microservices is all about autonomy. And to get maximum autonomy, you also don't want to share all your business logic in shared code, because otherwise you make a change and you have to coordinate with all the other microservices team. So keep sharing business logic and shared code to a minimum. Of course, there are some challenges with microservices. My talk is titled Fix Your Microservices Architecture after all. So there are so many services. And you have to first know, how do we actually find them? And when you find them, you need to know how to use them. Another challenge is you build an API. This works only for your web front end. Then you need to build almost the same API, but just a bit different for your mobile clients. Hopefully, mobile is just going to be one API. But even if you do it worse, then it's going to be both iOS and Android. And of course, there are also API users for machine-to-machine communications. When you share your APIs and you make a breaking change, you have to coordinate this with the other consumer of your API. So making breaking API changes in the microservices architecture is quite a challenge. Also, API design. You don't want to send everything to your client, because that would cause some performance overhead. But you have to figure out, do they actually need it? And then somewhere during your development cycle, you discover, oh, they need one more field and one more field. There are API schemas, even if you do something like REST. For REST, you have Swagger. But in my experience, they're not quite right most of the times. When you actually start to use the schema, I've discovered that, well, this nullable field is not there, or this API endpoint is not quite right, because they are sort of generated from code sometimes, but not quite right. So GraphQL, what can GraphQL do for you for your microservices? Of course, you fetch your data the same way. Whether you're a mobile user, whether you're an API user, you can make this one API work for everyone. This schema is also enforced. If you forget a field, GraphQL will actually tell you it throws an error, expected non-nullable field to be non-null, and it was null. And there's also no need to make breaking API changes. Facebook likes to mention that they've not broken their API since 2012, when they started with GraphQL. How do they do this? Well, with GraphQL, you can always keep the old field. Even if you make a typo, you can just keep the old field. Even if you restructure it, you can still keep the old structure. And it's not going to cause a performance hit, because in GraphQL, you will just fetch either the new field or the old field, but not both. In REST, it's going to be different, because you always get the old field and the new field. So with GraphQL, you can just add a new resolver, restructure everything, and it's not going to cause performance overhead. And nice thing is you can actually record which client is using which field. So if a field is not being used by anyone at all, you can just remove it, and it's not going to be a breaking API change, because no one was using it anyway. If you have a backend, you have a database layer. It's already sort of a schema of your domain. And with GraphQL, you can just say, well, expose everything I have in my database, assuming it's not the secret information. But if you do that, then at least you don't have to think, will they need this field or not? It's not going to cause a performance overhead anyway. You'll just query what they need, and you're done with your API design. Of course, this is something that you can get with Swagger as well. You can do code generation. So if you have a schema, you can generate your TypeScript types. This is also the case for GraphQL. The question is, will your team still have autonomy, which is what's really important in microservices world. So there are a couple of approaches, and wouldn't be an architecture talk without architecture diagrams. So this is the first approach that you can have. It actually has multiple GraphQL APIs. All these backend bits here are all different GraphQL APIs. The nice thing is you have the autonomy that you already had when you started off with your microservices. The search service and the search team can deploy separately from the review service and the review team. So autonomy check. However, you still need to make multiple service calls to combine all the data for a single page. If you're on the product page, you also need to query the review page. And if you're unlucky, you have this nice basket widget on every page. You need to query that as well. So you don't have the full benefit of GraphQL. You can't get a single query. This is actually an alternative architecture where you have a GraphQL gateway. And this gateway can combine all the GraphQL APIs into one. The challenge is, how do you preserve autonomy here? Because this GraphQL gateway, if that contains a lot of shared code, it's still going to be causing less autonomy. Maybe if you're familiar with microservices, there's a nice book and a nice website, microservices.io. And there's all the different API patterns and backend and frontend patterns. And this is actually API gateway. You might recognize this from the previous image. You have some front ends on the left side. In the middle, you have a gateway. And then on the right, you have some services. This is definitely an old picture because it still has REST on there. It's going to be GraphQL, of course. So let's look at some sample data. So this is some really joined together data. All data is connected. If you look at the user has reviews. And then you look at reviews, and reviews has products. But the review also has users going back to user again. And the product has reviews. So basically, this is all interconnected. So you would say, maybe I just combine everything into one, call it a big microservice. But yeah, at some point, you're not really doing microservices anymore. And I can imagine that something like reviews is not even in your own control, because there are services where you can actually buy reviews. If you're selling Nike shoes, I'm sure someone else has bought them before, left a review, and you can just buy them. So yeah, sometimes when you're looking for a quick way out, you think, I'll just copy some data. For example, the review author, I could just copy the name. That might be enough. But then you click the author, and then you want to see some more information. Well, that's not going to be enough anymore. You have to make some splits. And that's what you can do with GraphQL Federation. So GraphQL Federation is a replacement of schema stitching. In schema stitching, you still had lots of shared code, but that's been solved with GraphQL Federation. It's a central service that joins together your multiple schemas, like we saw in the architecture diagram. But yeah, every service can define how to join with other services themselves. This means that every microservice team can define how they join their data with other microservices teams. And that means that they can always deploy to production. So they're still autonomous. But you end up with a data structure like this. So the user team is responsible for the user and the name. The product team is for the product name. And also the relation between the user and the recent purchases. And the review team does some review data and the relation between the product and the review. And that way you can split up your domain and make it work. Now that brings me to the demo. And let's see how this will work. Really confusing. Let's start up the backend and the services and the gateway. We have 4 microservices starting at the same time. And now I'm gonna run the gateway. And the first thing the gateway is gonna do is actually query the different backends and see what they look like and what their schema is and how they join together. So you see this in the top window if I press enter. Starting up the gateway. And then you see all of the response data with the information. Not gonna get into this into much detail. How's this for the screen share, by the way? Is this still on there or what? So here I have a query, which is actually querying user data. It's querying my name, and then it's querying review data from the review service, and then also products data in the same way. If I look back to what's happening, you see this is the review data that's being returned. There's this bit, and then you have products. You have some information about the product. And here you have something about the account. So you have 1, 2, 3 services being called in a single call. Now, if I go to the service in isolation, I can actually do a get product by ID. I'll do it manually, and this is what's happening on the background. So this is the Federation internals. Typically, you don't have to look into this, but here I'm querying for entities, and I pass in a partial product, and from this product, I want to know the name. So when I run this, should do something. I think I should. There's a typo here. Probably removed a bit too much. Yeah. So here you see that product 2 is actually a couch. So that's what's happening in the background, and that's what the Apollo Federation implementation does for us. So what type of features do you have? You can actually extend an existing type, like a product. You can add a product name, or you can add product reviews. You can even calculate values, like shipping. Shipping can be calculated based on the weight of the products, for example. So why federation over schema stitching? There's no gateway that has shared code, which was the case in schema stitching, where you have to define how the product and the reviews are stitched together. There's also no type name conflicts across services. You can just type in extend product, and it'll extend the product. Everyone can use the same name for their types. And now the Apollo Federation implementation will do some efficient querying. You can imagine if you have a product list and in fact see the connected products, and then the reviews, and then the products again, you can do some optimizations there. So who does support GraphQL Federation? Well, Apollo, no surprise there. It even works for the JVM. If you're doing microservices, you typically are a bigger company, and the ones that I've worked in do a lot on JVM. GraphQL Kotlin, a really nice implementation, actually. I quite like it. And also, if you're doing TypeScript, you can do some code generation there, and it supports Federation. Unfortunately, not everyone supports it. Like in Nexus.js, it's a way to build code-first GraphQL APIs, which is different from schema first. Sangria, it's the Scala implementation, and Go GraphQL also does support it. Now it's thinking, well, that's unfortunate. What if you really want it? And that's when I came up with GraphQL Transform Federation. So what does this do? It'll be a small wrapper on which you can add the join points. Where is the product being extended with the reviews? And you add that as a layer on top of your GraphQL service. And that makes it possible not only to make your own service available for Federation, it also makes it possible to make managed GraphQL services available for Federation. So for example, if you have a CMS which has a GraphQL API, you can use the Transform Federation to add the annotations and make everything work. So here I have an example with managed GraphQL services. This can be a network hop, but it doesn't have to be. You can also use it as a wrapper internally in your own Node.js process. So please, after this talk, check out GraphQL Transform Federation. Internally, it actually reuses quite a lot of Apollo code, so it's fully compatible. Do note that it is running on Node.js. So getting started with GraphQL, there are various ways. You can add a GraphQL API to your existing API. If you have a REST endpoint, you can just add /GraphQL next to it. What you can also do is actually wrap your existing API. So you can write a GraphQL layer from scratch, and then internally do a REST call or Thrift call or whatever you were doing before. Or you can actually convert an existing REST API with swagger-to-GraphQL, which is an approach that I like, because you already have a REST API. If you're doing it right, you already have schema definitions there. You can just generate all the GraphQL. Nice thing is it also has the same security that you have in your REST API. You're just wrapping your public API. So all the throttling, authentication, it'll still just work as it was before. I discovered swagger-to-GraphQL even runs in the browser, which makes it nice for demos. And note that you want to do this as for an experiment. You don't want to call REST APIs in a wrapped GraphQL schema in your browser, because we're already shipping way too much JavaScript. You want to do this on the server side. You can even bring your own HTTP client, so you can do your own authentication. And you can use schema stitching to do the join points between REST resources. I say schema stitching instead of federation, because federation only makes sense across teams. So I made some improvement to the project. It was written in Flow originally. I converted it to TypeScript, added some support for OpenAPI 3, and I added the bring your own HTTP client. So which brings me to the demo. I'm not going to be switching the screens anymore because that was not great. So I'll type behind me. So if you go online to the URL above, you can find this if you Google for swagger-to-graphql. Then you get this graphical interface. It has the nice GraphQL Explorer. So you don't have to learn to type GraphQL. You can just click these checkboxes. You get this query. And then you're already getting the first error, which is actually a great example of why Swagger can't be trusted. It returns null for a non-nullable field. Name should not be null. I'm not sure how they managed to do this. This is a public API. You can create your own pets on this API. But people managed to get pets without a name. So if you remove the name, then you actually see it working. Now it's actually querying all the different pets. So I'll add in the get inventory. And I'll open the network tab. So what you'll see here is if I run this again, it'll do 2 HTTP calls, 2 REST calls. See, find by status and inventory. Notice I'm doing course anywhere because we don't want those headers anywhere. Being sponsored by Heroku. But there you see it's fetching it. And you can try this out in the first day. Get yourself a GraphQL API, give it some swagger. Yes, I'm getting better at this. So there's also some concerns. I've brought up GraphQL at a couple of clients. So yeah, one of the concerns is actually real. What about malicious queries? GraphQL is so capable that in one query you can query your entire database and all the data in your company, and that would take so long that it's not something you want. Another thing is that yeah, GraphQL breaks cacheability. REST was great for caching, and in GraphQL it's all going to be wrong now. Another concern might be, well, we're a Java shop, we don't do Node.js. Node.js is slow and we don't like it. So yeah, for malicious queries, if you can, use query whitelisting. This is possible if you'll be the only one consuming your GraphQL API. You can upload all your queries before you go to production and only support those. So there's not going to be any malicious queries. Apollo has automatic persisted queries. This happens at runtime, where they'll hash the query and they use the hash in the URL. If you then capture this before you go to production, you can have disable random queries on production. There's also a product called Persist GraphQL. I actually quite like this because this would parse out the GraphQL out of your TypeScript, so you can do it at build time instead of at runtime. For some reason, it's been archived though, so I wouldn't advise to use it, but yeah, it's still a really cool project. GraphQL Java has a system called query caching. It's a bit similar to persistent queries. But something you can also do, especially if you're doing like GraphQL to REST, you can just limit the REST calls that are happening. Or you can limit fetches to the database layer and just throw an error. And that way, if it's a malicious query, it's going to throw an error. And otherwise, it'll stop querying data. If you're going to go the full, most complex route, you can implement query cost analysis. So there's a JavaScript project there. There's a Java project there as well. And yeah, if you have these query cost calculation, then you can implement session-based limits, saying, well, this query costs you 10, and if you do 10 every second, it's fine. But if you do query of cost 10 100 times a second, it's not going to be fine. Check out this link. I'll share the slides. They use the leaky bucket algorithm, which is great for limits. So yeah, to be honest, I've been at many companies and I've never actually seen REST APIs being cached. I have seen cache breaking due to adding a timestamp on it, so you don't get an old version. In practice, yeah, it's often not cached. But if you do want to cache, yeah, you really do have an issue because GraphQL is going to be over a post to a /GraphQL endpoint, and you can't cache those. So the nice thing is that, well, if you use the Apollo automatic queries, then it's going to try to hash your query and then put the hash in a URL, and it tries a GET request first. So it's going to do something like /GraphQL /query hash equals, and then the query hash. And that's great for caching. And another feature is an add cache control directive. If you put this on top of your GraphQL API, you can say cache this for a day and cache this other bit for a minute. And then it'll combine all of the cache control directives, and it's going to take the lowest one. So it's going to be cached for a minute in this case. So another concern, Node.js is slow. And yeah, the downside of Apollo Federation is it's only implemented in Node.js. Well, the nice thing is if you're coming from REST and you're going to GraphQL, then GraphQL already has performance benefits because it will do all the data fetching in a single call. So it's already going to be faster. Also going to return a smaller response, so it's already faster. So maybe it doesn't matter that Node.js is slower than Java or Go. But yeah, if you do really try to test it first and test for the user experience mostly, and not on a single millisecond. If you have like an API call that takes 10 milliseconds, now taking 20 milliseconds, you're going to say, wow, this is twice as slow. But then you have JavaScript parsing and interpreting for 2000 milliseconds. It really doesn't matter that much. But if you do, if you don't need Federation, yeah, you can use GraphQL Java and Go on the backend, use something like that. But also an interesting approach that I've not seen much, but I really like the idea. JavaScript doesn't have to run on Node.js. There's actually alternative JavaScript engines. And on the next slide, I have an example here of ES4X. And ES4X is ECMAScript for X, and it's for Vertex actually, and it's running on GraalVM. And GraalVM is a reimagination of the JVM. So it's like Java, but then way faster. And it gives, the framework itself is really fast if you compare it like this. So ES4, it's like 4 times as fast as Node.js. And well, this benchmark doesn't have any GraphQL in it, but this is doing a single query and then translating it into multiple queries into a Postgres database. And it's really ridiculously fast because if you look at the bottom, it's really gray, light gray, but it's request per second. So if you have a single Node.js instance, they can do this benchmark like 900 times a second, which is already pretty fast. But then ES4X is like over 4,000 times per second in a single instance. So really check out the ES4X and GraalVM. So wrapping up, Federation allows you to preserve team autonomy when using GraphQL in the microservices landscape. GraphQL Transform Federation enables you to use Federation everywhere, even if your backend doesn't support it yet. And swagger-to-GraphQL lets you try out GraphQL today. So there are many benefits over REST, and there are solutions to the downside. So I would say, simplify your microservices architecture. Just use GraphQL. Thank you.